Hi everyone, this is Ibrahim Siddiqui with you. I'm very excited today to show you another video, and this video will be about risk appetite and risk attitude. What you are going to see is more about the terminology and concepts that were built around risk averse, risk seeking, risk tolerance, and all of this that comes from the behavior and willingness of the risk. So it is more qualitative than quantitative. So in the next coming videos, we will start doing some mathematics and to show the quantitative aspect of the risk. But for today, I will just be talking about the risk appetite and the risk attitude. So if you go to any um, search engine like Google or ChatGPT, and you just type what is risk attitude, you get something similar to what you see in the screen right now. So in project management, risk attitude refer to how individuals or organization perceive, approach, and respond to that particular risk. So this attitude shape how decisions are made under uncertainty, so which means under probabilities, likelihood, and influence how risk are identified, assessed, and treated throughout the project lifecycle. So you may find similar definition, but it means the same thing. So risk attitude is how we choose to respond to uncertainty that matter to us. This is very important because you may be sitting in your sofa right now uh, and everything looks fine. So the probability that something will happen to you, it will be very, very low. So the risk is not matter to you. But if someone is sitting in gas station or working in the plant, the risk for him or for her, it's very important and it's matter for them. So it all depends your situation. That's why it's driven by our perception of situation. Risk attitude is the choice an individual or group makes when facing specific risk situation. So influenced by various perceptual factors. There are many factors that we perceive to be parts that contribute to our risk attitude, means to our behavior. Risk attitude exists on spectrum. There is a wide range of possible response, and all of this response can be categorized in risk averse, risk seeking, risk neutral, and tolerance. All of these words are shorthand to describe these different responses. There is a very interesting graph that you see on the screen right now. This one was developed by Dr. Dave Hilson, and I took it from his book, I believe, Managing Group of Risk Attitude. Yes, Managing Group Risk Attitude. He explained it very well, and you can check his book. So the good things here, so he made very interesting relationship between risk tolerance and risk seeking or risk averse. So basically, when risk tolerance is large, so the risk seeking will be less, and vice versa. When the risk tolerance is low, risk seeking or averse will be high. So you can see it here um, like this, for example. So you can see the range of the level of discomfort, the range of the level of discomfort if it is a risk averse, and here the range of the risk level of comfort to risk. So, so basically, as we said, that the risk attitude exists in spectrum. So if you, for example, you decide or the team decide to behave or to be, they get an attitude to be in risk averse. So they have a spectrum, they have a range, how much they can be in this region. The same thing if they are in risk seeking, so they have a range of um, from the attitude perspective. And what dictate this is the risk tolerance. So in the next coming videos, so I will be talking about the risk tolerance and how we can model it. So bottom line, that risk appetite is about what you are willing to risk, what is your willingness to accept that kind of risk. And the risk attitude is about how you behave. So we can link the risk attitude to the behavior and the risk appetite to the willingness. So, and another concept that I would like to introduce is about the utility function. So the utility function uh, or the satisfaction within the context of the project. So the utility function was developed by von Neumann and Morgenstern back in the 40s, and it is used mainly in economy to model the consumer behavior and other things that utility can be used. So, so the graph shown in this screen describe different stages of an adaptive risk attitude. A concave curve, like this one, like the red one. So this is the concave. So this concave suggests risk averse attitude, while a convex curve shows risk seeking or loving, so which is the green curve. And you have a set of them, okay, so with different risk uh, tolerance. So RT, for example, the the higher one has a risk tolerance 1, and then inside the risk tolerance 2. So you can see that the risk tolerance is increasing. So a linear curve demonstrates a risk neutral attitude. So you can see that when the risk tolerance get higher and higher and higher, you get this line, okay, which represent risk neutral. So the concave convex shape is dictated by the sign and value of risk tolerance, as I explained. So the largest value of risk tolerance in magnitude bring the concave convex shape toward linearity, which will derive a risk um, neutral attitude. So and then the x-axis represent the cost. So this is where the x-axis. So we have this is represent the cost, as you can see here, and the y-axis represent the level of satisfaction or utility. So in general, this is the terminology, scientific terminology, but within the project, we can say this is the satisfaction or preferences. So note that the utility function or satisfaction is bounded between 0 to 1. So you can see here 1 and you can see here 0 because it is scaled. So I will show you the mathematical expression. So the low cost, so because here the low cost here has the highest satisfaction. Of course, when you spend less, you will be happy, you will be very satisfied. So the low cost derive high satisfaction, while high cost um, um, insinuating low satisfaction, as you can see here. So this is the high cost, then very low or zero satisfaction because you spend more than what you budget for. So so we can say that since the utility function or satisfaction is bounded between 0 and 1, so the cost must also be bounded between low and high, as you can see it here. So it is bounded and then here. So the curve is bounded in terms of cost between low cost and high cost, and is bounded between low satisfaction and high satisfaction. So we choose to have the satisfaction between 0 and 1, and I will show you this in the next video where we derive the expression of the all of this, the mathematical expression of these curves. Okay, and also we have, as we said, that the u law. If I say u, the function u of low equals 0, and u of high. Sorry, this is low. Sorry. This is high, and this is low. Okay. And also we have another parameters where we talk about the payoff H, as you can see here. So X0 is your budget, is your point of estimate, if I can say that. And you have certain payoff, certain costs that you can add if you are risk seeking. So, and the maximum, you cannot go forever to the infinity. So you need to define the higher cost. So we define the higher cost by taking your budget plus your H. So what is the expression of this H? And we will see that in the next videos. The same thing, you subtract x0 minus h, you get low, and you define this utility function. So the mathematical expression for each of these curves depend of risk tolerance, as you can see here. So and also to the high and to the low value and the risk tolerance, as you can see here. So, and then Of course, the risk tolerance should be different than zero because you are dividing by zero here, by value. So, and this value cannot be equal zero. So when risk tolerance is large, goes to infinity, then you will be in this situation. And this is only for risk neutral. Note that for the risk tolerance here, if it is positive, you have a positive risk tolerance. This indicates this is a risk seeking. If you have a risk tolerance negative, then this is a risk averse. So we will see the mathematical of all of this in the next videos. Also, very important observation that the expected satisfaction, it's always equal to half. So which means at this level, so let's say you choose a risk tolerance 3, for example, you plug it into this formula, and you know your boundary for low end, and then you can build this curve, right? So this curve will intercept at this point. Okay, there is only one point here. So, and if you do a vertical, you see that on the x-axis, this will give you XCE. So, and then you have the same thing. If you have a different risk tolerance, you get another XCE and so on. So all of this XCE, which is the certainty equivalent, which could be in a project, means actual cost or forecasted cost. So it all depends the attitude of the project team. If the project team they behave or they have an attitude as a risk seeking, so which means risk loving, you can expect that the cost will be higher than what was budgeted, right? So, and this was dictated by the risk tolerance, how much risk tolerance the group or project team have. The same thing if you go, if they behave or they have an attitude as a risk averse, they are very averse on their decision, on their attitude. So you get another XCE here, which is less than what you budget for, as you can see here, right? So we would like to know the expression of this actual cost or forecasted cost, or in scientific terminology, we say certainty equivalent. So you can also see that they have all of them, all of these actual costs, they have the same satisfaction. They have the same satisfaction. So which means you, if I put it in this way, U XCE for a particular risk tolerance equal all of this expression, exponential blah blah blah, and then XCE minus high and so on. Okay, so and then we can derive this expression. I will show you how we come up to this expression in the next video. Also, I define the risk tolerance as high minus low. And then if you substitute the expression of high, so you can say risk tolerance equal x0 plus h minus x0 minus h, and then you time by systematic risk beta that we will define later on, and you can, the x0 will be simplified, and you get the expression, sorry, RT equal to H beta, as you can see it here. Thank you very much, and hope that you will stay in the following me in this series of revolutionizing project control. See you soon, and stay tuned. Thank you.